Today's lesson is for AB Calculus only because BC combines this one with the one we will do in class next time. We are beginning work with related rates, and this is going to involve using some of our skills we learned earlier this semester for implicit differentiation. So if you'll remember, if you had something like x squared equals x plus y, and you were asked to take the derivative of that with respect to x, then you would take the derivative of any term with just an x in it as usual, so that'd be 2x, and that'd be 1. Oops. There should be an equals there. But the derivative of y with respect to x was dy dx. Also, if you had something like 24 equals 3xy, you would take the derivative of 24, which is 0, and then over here you'd have to use the product rule, splitting this into two separate functions, 3x times y, which means you'd take your first function, 3x, times the derivative of the second function, which is dy dx, plus the second function, which is y, times the derivative of the first function, which is 3. So anytime you were taking the derivative of y, you made it dy dx. Well, today in related rates, we're going to do something really similar. Our first example that actually has to do with new material is we are going to take the derivative of every equation we work on today with respect to time. So I'm going to start with the area of a circle formula. Now, there is no variable time here. There's no t in the equation. And there's not going to be on any of the problems that we do today. But what you need to know is that every variable in the problem is going to make a rate. That's important to remember. Every variable generates a rate. Okay, so when I'm taking the derivative with respect to time of a, that's going to be dA on top, dt on bottom. Just like when I was taking the derivative of y with respect to x, it became dy dx. Okay, so basically everything's going to have dt when we do our rates. Now here, to take the derivative of pi r squared, you need to remember pi is a number, not a variable. So I can just use the power rule here. 2 times pi in the front, r to the power of, take 1 away from the power, so that's 1. But then I must multiply that by dr dt, because every variable generates a rate. So that's the answer to that problem. And by the way, the examples that I'm doing today are coming from homework problems, but not in the order I'm presenting them. So here's another one. Area equals 1/2 BH. This is the formula for the area of a triangle. Now, we're going to differentiate this with respect to time. So again, the area is going to be dA dt. But when I take the derivative of the 1/2 BH, 1/2 B is a function, H is a function. This is a product rule problem. I need to use the product rule to do this. And I should anticipate, since I have 3 variables in the original problem, I'm going to have 3 rates. These are my rates, the dA dt's or the dB dt's or the dH dt's. I'm going to have 3 rates in my answer. So the product rule says I take my first function, which is 1/2 B, and I multiply it by the derivative of my second function. The derivative of h with respect to time is dh dt, plus my second function, which is h, times the derivative of my first function, the derivative of 1/2 b, would be 1/2 dB dt. And that's the answer. Alright, number 3. Cosine of theta equals x over h. Now, this looks like I might have to use the quotient rule on the right-hand side of this equation, but I don't have to if I rewrite this as the cosine theta equals x h to the -1 power. Now I can use the product rule, which is a little bit easier. So, what is the derivative of the cosine of theta? Well, negative sine theta, but since I'm taking the derivative with respect to time, I must multiply by d theta dt. And then I'm going to use my product rule on the other side, so I take my first function times the derivative of my second function. So I'm going to use my power rule. -1 comes in front. H, subtract 1 from my power, so that's to the -2 power. Times, since I took the derivative of h with respect to time, dh dt. Plus second function, h to the -1, times the derivative of the first function. The derivative of x is just 1, but I multiply by dx, oops, that's an x, dt. And there's my answer. Okay, number 4. This one is a little bit sneaky because I need to tell you a rule that we didn't really, we did kind of look at it the day we did the worksheet with the cow on it. Memories. But the derivative of u times v times w, so this is like the triple product rule, is equal to u prime vw plus u v prime w plus uv w prime. So we're going to do the volume equals length times width times height. That's a volume of a rectangular prism. Now we're going to take the derivative of this with respect to time. So the v will become dv dt. Now, when I take the derivative of this LWH, I'm looking at it like it's UVW up here. So I'm going to use this formula. And instead of doing primes, since I'm doing it with respect to time, I want to make sure to do it with the dL dt, which would be the derivative of the first factor in my product, times WH times the other two, just normal, plus the derivative of the second factor in my product, dW dt, times just the other two, normal, plus the derivative of the last factor in my product, dH dt, times the other two, LW. And that's the answer. So, I just did 1, 2, 3, 4 of your 14 problems on the front page of your homework. Now, we're going to take a look at a few that are on the back. We have the surface area of a cylinder. Okay, surface area of a cylinder. Do you remember that formula from geometry? A lot of these are geometry formulas we're using today, although some are pre-cal. We want to find the rate of change of height over time. So find dH dt, the rate of change of the height over time. So surface area of a cylinder is 2 pi r h. If you remember, 2 pi r is the circumference of a circle times the height. That gives you the lateral area, plus the two circles, 2 pi r squared. Okay, so I'm going to take the derivative of this formula with respect to time. So ds dt equals, notice here 2 pi r has a variable, h is a different variable, so that's a product rule situation. I'm going to go first function times the derivative of the second plus second function times the derivative of the first function, which would be 2 pi and then r to the 0, so just 2 pi. But I've taken the derivative of r with respect to time, so dr dt plus, now I can take the derivative of this last piece here, 2 pi r squared. So my 2 comes out in front. I multiply 2 times 2 to get 4 pi r to the first power times dr dt. Now, this was all we had to do on the other problems, which are like the ones on the front of your worksheet. We would stop at this point. But on the back, they're asking us to actually find this specific one, dh dt, which is right here in our equation. So basically that means they want me to isolate that. So in order to isolate it, that means I'm going to take this term and this term and move them to the other side of the equation away from the dh dt by subtracting them. So that's going to be ds dt, which was already on the left side, minus, I'm going to call it 2 pi h dr dt plus 4 pi r dr. Ooh, I hope you caught my mistake there. That should be a minus dr dt equals 2 pi r dh dt. So now, in order to get this dh dt by itself, I could divide both sides by 2 pi r, or I could multiply by the reciprocal 1 over 2 pi r, which might be a little less complicated, but that might be a personal preference. So 1 over 2 pi r times ds dt minus 2 pi h dr dt minus 4 pi r dr dt equals dh dt. Now another thing that you could do to make it look a little bit simpler is to take this dr dt here and factor it out of just these two terms because it's not present in that last one. Again, that's kind of a personal preference. 1 over 2 pi r, it would look like this if you did it. ds dt minus another inner parentheses 2 pi h minus 4 pi r. Oh wait, if I pull the minus out in front, that should be a plus. Dr dt equals dh dt. Now, keep in mind that when you do this, as long as your answer is algebraically equivalent to the correct answer, it will be accepted on a free response question. If it's a multiple choice, you will have to find the one that matches with yours. So if it's not in the format you have, you'll have to try to figure out which one is algebraically equivalent. Sorry about that beeping. That was my timer going off for my breakfast being ready. Doing this in the summertime. Let's see, what's today? June the 20th? Yep. Okay. Next problem. number 6. We're going to do Pythagorean theorem. And we're going to find the rate of change of the hypotenuse over time. So Pythagorean theorem is a squared plus b squared equals c squared. And I want to find the rate of change of the hypotenuse, which means dc dt. And I'm going to isolate that. So my first step is to just take the derivative of this with respect to time, like I did on the earlier examples. So this is going to be 2a dA dt plus 2b dB dt equals to c dC dt. And then the next thing that I have to do is isolate this dC dt. So I can either divide both sides by 2c or multiply by 1 over 2c. I'm going to multiply by 1 over 2c. And now I've got dC dt by itself. That's the answer. So that was a little bit easier than the last one. Okay, I'm going to do one more with you, and then I'm going to leave the rest of them for you to work as homework. Last example here. Today's lesson is kind of easier. I hope that that means you have a lot of time to go over last time's homework in class if you had any questions. Area equals, area of a sector of a circle. And we want the rate of change of the angle over time. So area of a sector. And in calculus, this would always be in radians, not degrees. You learned this formula last year in pre-cal. And we want the rate of change of the angle. So in radians, the angle would be theta. D theta dt is what we're trying to find. So what is that formula for area of a sector of a circle that you learned last year in pre-cal? 1/2 theta r squared. Oh yeah, I remember that now. Okay, so we're going to first take the derivative of this and then isolate d theta dt. So dA dt equals, this is a product rule situation. We have two variables. Theta is a variable and r is a variable. So I'm going to say first function, 1/2 theta, times the derivative of the second function, which would be 2r to the first dr dt, plus second function r squared, times the derivative of the first function, 1/2 theta to the 0, which is just 1, d theta dt. Okay, now I want to get this d theta dt by itself. So I'm going to take this part right here and subtract it from both sides. So I will have dA dt minus 1/2 theta 2r dr dt equals 1/2 r squared. I reordered those, d theta dt, because multiplication is commutative. Now, I can either divide both sides by 1/2 r squared, or I could multiply by the reciprocal. And if I want to multiply by the reciprocal, I actually might want to think of this right now as r squared over 2. So then when I flip that fraction, it's 2 over r squared. So I'm going to go 2 over r squared times dA dt minus, now these could actually be multiplied together here. 1/2 times 2 is just 1. So this could be theta r dr dt equals d theta dt. And that's the answer. Alright, That was a shorter lesson for today. Hopefully you get lots of good practice working with taking the derivative with respect to time. All these formulas, we're generating rates for them so that we can look at how one variable changing over time will affect other variables that change over time. It allows us to solve a little bit more complicated problems in calculus. So good luck on your worksheet homework, and that's it. Bye.